for the digital twin to work, we need enormous amount of data, right? In the network, what happens if there is a disruption in a train service? What happens if that train link gets impacted? What is the impact on the entire network? It used to be a fixed traffic signal,
Correct,
right?
correct.
So we go there, we collect the data, we count how many number of vehicles are manually count, and then we try to actually modify that green time, red time based on the number of vehicles.
Right.
If there is no vehicle on an approach, there is no need of a green signal. In the next 10 years, what we are going to see is flying cars.
Hello and welcome to this episode of the Professor Mahesh Podcast, your resource to help you make informed career decisions. As we like to think, this is your future simplified. This podcast is brought to you by IITM Global, an initiative of the Office of Global Engagement at IIT Madras. IITM Global is our platform that helps take IIT Madras to the global audience. Our startups, our research, our philosophy broadly. Come learn more about what IIT Madras Global stands for in the links given in the description below. The topic for today's conversation is going to be transportation. Transportation of people mostly, but transportation of goods, which is sort of used by very similar or the same systems, and the underlying principles that govern the design of these massive transportation systems globally. These transportation systems transport people locally from within a few kilometers to tens of thousands of kilometers. To help us understand this space, I have Professor Divya Nair from the University of New South Wales in Sydney. Let's start by talking about your own life journey. Where did you start off and what led you to this career in transportation?
Thank you so much for having me in this podcast. I did my undergrad in civil engineering and then did my master's in transport engineering. My curiosity to transport really started when I started observing the transport networks, observing how people move from one place to other. That led me to take transport engineering as a master's specialization. Then I did my PhD in transportation engineering, but when I did my PhD, I did focus a little bit more on application of operations research in transport. So I did optimization and moved away a little bit to logistics. My PhD was specifically on humanitarian engineering. So I would say it's an interdisciplinary field where transport and humanitarian engineering comes together. So I did my PhD on developing decision-making models for food rescue and delivery operations. In Australia, we do have several organizations who actually pick up surplus food and then deliver it to people in need. So I did work with the Australian government to build decision-making models for those organizations.
That's fascinating. That's an area that I'm sure many of our listeners, in fact, the word humanitarian engineering, I am hearing for the first time. I'd love to learn a little more about it. But when I was doing my research, our research on your background, one paper really piqued my interest on a recent paper of yours on traffic jams and how urban systems get hit. Nobody out there has not been in a traffic jam. So tell us a little bit about what was that work about? What did we learn there?
So a traffic jam is a very common to common people, right? So there is nobody in the world who has not experienced that. So when I start my lectures to the student, I would say that transport is one of the discipline that's very close to everybody's heart. You see that in everyday life, right? So yes, so that paper was in collaborations with Google, if I remember correctly. If I understand, you're talking about the characterization of traffic congestion.
Yes, that's right.
So what we did is, so in transport and traffic engineering, the key is data, and collecting data for the entire network is immense and it's very expensive. So what we collaborated with Google on getting crowdsourced data, looking at the application of crowdsourced data in understanding the traffic patterns, traffic congestions. When do you have this traffic congestion? Do you have this traffic congestion in the entire network or only on certain areas? Or do you have the congestion throughout the day or only on a particular time of a day? And is the traffic congestion pattern the same for throughout the country, different states, or across the world? So we did do this analysis for a certain number of countries. We picked some developing countries, underdeveloped countries, and developed countries and characterized the traffic congestion pattern and then did some analysis and comparison on how it looks. And how this leads to many other problems like accidents, how it leads to emissions and so and so. Actually, that's a very interesting paper. Because of that work, we were approached by UN to do traffic congestion modeling, which then feeds into their emission modeling.
Wow. So, tell us a little bit about uh, transportation systems broadly. What are these systems that drive people, that move people around? And as you were beginning to say, transportation systems are like fundamental enablers of human creativity or human endeavor. So tell us a little bit about what is the basic design of these systems, and then we'll talk about other things.
Yes. So let's call it as mobility because that's the right word, right? The transport systems actually enables mobility, right? People can move from one point to another. If they are not able to move from one point to another, how do they reach to the services, right? So let's say mobility. So it's primarily sit under the civil engineering department, but then transport is an interdisciplinary, multidisciplinary field where researchers or practitioners from different fields come together and work together. So yeah, so and again, transport itself has various domain. So I do work on the logistics operations research side of transport. I also work on transport traffic management side of transport. Again, it comes under optimization or logistics, where you look at evacuation and transport network resilience, and then transport network systems itself is another area, another discipline. Demand management, that's another major discipline within transport. So we do have, so if you go to any transport discipline and look at the academics or the engineers working in that, you will see that there's people working on demand modeling, there are people working on transport systems, working on network analysis, traffic management. So it's a multidisciplinary area.
And it also, to me, seems like the closest of all civil engineering disciplines to computer science.
Yes, yes. Because we deal a lot with data. Because transport systems, to analyze the transport system, we need data. And it's a huge, big data that we deal with. So it's very closely related to, we closely work with computer science. So I tell my students, you get into any transport industry, especially the government organizations or any transport industry, when you get into the room, you're not going to talk just to a transport engineer. You're going to talk to a computer science engineer or a data mining or a data scientist. So you see this interdisciplinary practitioners working together.
Hmm. And the data that civil engineers, the transportation engineers deal with, comes from what sources? Comes from, what are the different sources that you work with?
Primarily, it is the counters that we have. So you might traffic signals, and then you might have seen the traffic counters along the traffic signals, sensors that we call different types of counters. I would say some are visible, some are not visible. There are video cameras. So those count data that comes through from sensors. And then we do have crowdsourced data that we get from Google, TomTom, various other ways, various other sources. So these are the major sources of traffic data.
Okay. Let's step forward and talk about the conceptual frameworks and the modeling approaches that underlie most transportation systems, right? So the first thing we should be talking about is the multimodality. And that when you talk of mobility, you're not just talking road transport or traffic. How do these systems come together?
They have to integrate together, and they come together. So if you look at the multimodality, right? Depending on the purpose of travel, you choose a particular mode of transport. That's what we do. We do have rails, we have road network. Within road network, we have different types of modes. We can have private cars, we can have public transport, there is active transport. So they all work together depending on the purpose of travel. That has a big role to play in how they come together. Right. So let's say public transport, right? It's one of the accessible mode of transport for the public, right? So
Particularly in India, there's
yes,
very large public transport system.
yes, and it is accessible to all.
Okay.
That's why we say it's one of the most important mode of transport, right? So, but the problem with public transport would be it might not be accessible to all in terms of the availability of public transport, right? So, the road network, the availability of road, how far do you have to walk to the best station to reach a public transport? So that actually reduces the usage of public transport. So how we can incentivize people to use public transport? Because if you have an option, those who have an option to use a car and a public transport, they might go for car because it's more comfortable when compared to public transport, right? So, and also car is door to door transport as well. So if we can improve the door to door transport by adding some last mile, first mile component into public transport, so that's where I say multimodality comes together to improve the transport system.
Have there been any example? That's a very interesting concept. Have there been any examples where public transport has helped the first mile and the last mile? Because when I think public transport, I'm thinking bus stop, bus stop.
So actually adding a last mile and first mile will incentivize public transport. So when you add an active transport component to the first mile or the last mile, that means you are in a way giving an door to door transport, right? Before you have to walk for 15 minutes to reach a bus station to catch a bus or a train station to catch a train, but you add an active transport component to it, that travel duration will be less, and then people will choose public transport over car. That's what we want, right? Because all these traffic congestion on the road is because we have more number of people using cars instead of public transport. So how we can reduce the usage of car, how we can improve the usage of public transport, that's when all these last mile, first mile intermodality discussions came into picture.
Okay. I think underlying all this is, of course, human behavior,
Yeah.
right? And I can't hold myself anymore. We have to talk about humanitarian engineering, that you said. So let's talk about what do you mean by humanitarian engineering and how do you bring that into mobility systems design?
Before, we used to build the system. We used to build the transport network for the vehicles. It's based on, now it's more user centric transport system. That way we bring in the human aspect into the transport network design. So humanitarian engineering is a bit a different aspect of it, a different area, I would say. So let's first talk about how we bring in the human aspects of
Yeah.
transport.
Idea. Yeah.
Right? Because initially, when we used to do transport modeling, what we looked at is how much demand, what is the supply, and whether do we have enough supply to meet the demand. When we don't have enough supply to meet the demand, that's when the congestion happens. So how can we deal with that, right? And that was the main concept. Now, not just looking at the number of people using, looking at the behavior of people using as well, right? So we do have different types of users, right? We have women, we have male using the transport network. We do have different age people using the age category using the transport network, and everybody has their own behavioral aspects as well. How do we integrate that into the transport system? Right. So this is another big area of research where interdisciplinary people come together to contribute towards the transport network system design.
And now you had earlier talked about your PhD thesis. Okay, let's go back to that. I think I can now see what humanitarian engineering means. So explain the complexity of that problem.
If you look at, it's basically an optimization problem, right?
Okay.
You're actually trying to optimize the routes, or you're trying to pick up something and deliver something. But I would call it as more of a humanitarian, because if you have enough supply to deliver, it's a simple pickup delivery problem. But with the problem which I was dealing is, we do have very less surplus food, right? And that surplus food, that's the supply we have. The demand for that surplus food, that is the welfare agencies or any agencies which rely on the surplus food, is huge. So we do not have enough supply to meet that demand. So how do you deliver that, right? So do you deliver to the first five delivery point and then, okay, I'm done with my delivery. I do not have enough any more supply and that's it. Is that how you route? That's more cost efficient, right? You just travel maybe you just do 5 visits and cost efficient. But is that what we want to achieve? Do you want to serve everybody in the system, right? When you do not have enough supply, how do you make decisions on how much to deliver to all, right? Do you want to make it more fair, more equitable? Say we have 100 kilograms of rice, right? And we have 10 agencies waiting. So if we divide that 100 equally among the 10 agencies, I can say although the demand for them is more than 10 kg, they may not be able to meet all the demand, but give some to all. How do you make that decision? Right? Is it equal distribution? May not be, right? So sometimes some agencies might be the children who are waiting for their meals for the school, or some might be the old age welfare agencies. How do you make decisions? Right? That's where my research was. So how do you equitably distribute the and again look at the surplus food we have. This is the extra food at the restaurants or at the supermarkets, which is near expiry and it has its perishability as well. So, if you do not deliver within time, it's actually going to go into the landfill. You don't want that, right? Which could have been used for people in need. So, before it goes to the landfill, how can you divert that to the people in need and more equitably? That was the project. So, I prefer to call it as a humanitarian problem that I dealt with rather than transport. Although what we are doing is just pick up and deliver.
Sure. Fascinating. I think the problem itself cuts across multiple countries, even though you may have taken Australia as a case in point and worked with Australian data. The idea is relevant to
Yes.
hundreds of countries, right? And when you now add the ethical element, as you know, you said it's important to deliver food to children because they are their needs are different and more immediate. When we talk of transport systems, you know, at least let's again keep ourselves to public transport. Public transport systems are not optimized for profit. That's not the motive of governments. So, what do you think some of the motives should be for a government to step in, and how should a policymaker think of designing these transportation systems? You talked of the ethical considerations and access considerations. How do we bring that in? What are your thoughts on?
So, not just public transport, any transport problem you take, right? So, it can have many aspects. So, primarily, you see, whenever we deal with a transport problem, we try to minimize the travel time because that's what people want. They want to reach the place as soon as possible. Right? That's one criteria. But if we try to do that, what about the other elements that we are missing? Right. For example, if government wants to fund a project, right? So they might have different alternatives in front of them. So how do they make judgment on which alternative to go for? Are they looking only at the cost benefit analysis, or are they only looking at the efficiency, or they are also looking at the carbon footprint, how much pollution related aspects coming out of it, or are they also looking at the equitable aspects, right? So that's the problem always operation research people deal with. We call them as multi-optimization problem or multi-criteria decision-making problem, where you have to make decisions based on multiple objectives. And you can see that if you try to improve the equity, it is actually contradicting the travel time. Right. So when you try to improve something, the other one is going down. So how do you balance this? How do you come up with a trade-off between these? So that's the crust of optimization problem. That's that's something which you see in any transport problem. Right. So if for the government to improve the public transport usage, it should be accessible to people. When I say accessible to people, I know public transport is not that expensive for the people. That's why people use it.
Sure.
But then where do they have the bus stops? Do they have to walk another 2 kilometers to reach bus stop? Accessibility in terms of distance, right? But then when government tries to make it more accessible, it has to travel a little bit more distance and it comes with more cost. So is it is it worth spending that extra cost? That's one decision which government takes, right? So there is two objective functions there. One is in improving equity by improving accessibility. The other one is cost. So where do you come up with the balance? You don't need you can't put a bus stop at every house door, right? So where do you locate a bus stop? How do you identify the right location of a bus stop in such a way that you try to maximize the efficiency or the minimize the cost as well as accessibility to the people? So these are some examples I would say, but many more I can cite.
Hmm. So it's interesting. In Tamil Nadu, bus transport is free to women.
Oh, nice.
Okay. And that has completely changed the dynamic,
Mm.
as you would imagine. What you talked of equity in access, right? And so, for example, for a school child to ride the bus
Mm.
and go to a school versus a woman or a man taking a bus to go to work or to a market, the needs are different. A school child has to reach a school at a particular time. And so that becomes the overriding objective in some way. So, how do you improve equity in access itself? I mean, one is, like you said, you optimally locate the bus stop. So you are just like, and you also talked of this very interesting idea of the first mile,
Yes.
adding some connectivity at the first and last mile. Are there ideas that you have seen that sort of help that equity in access problem?
Uh, so we actually categorize the users based on their needs, right? So we call vulnerable group. There might be people in different age categories which require a different set of needs. So when we do optimization, we do have different weights allocated to different groups. So there is a way to actually play around with even within accessibility for different groups. So it can be done, and it is again data intensive process. So you do analysis to see where the weights should sit among different groups, and then that's how we integrate that in the optimization for.
You've said optimization now a few times. So let's talk about optimization. I think at the core of all of design, transport system design is one example. At the core of all of design is optimization. Tell us in simple terms for our audience, what is optimization?
Okay. So you have some budget and you're trying to achieve a set of things. How do you allocate this budget to achieve those set of things? That's simply optimization, right? So I get into a supermarket. I have $5. I need to buy candy for my daughter. I need to buy a Coke for my husband. I need to buy a chocolate for me. I have three things to do. How do I optimize the $5, right? How do I make this allocation? Whether I buy two candies or I buy one Coke bottle. So each of this has associated utility as well, right? So I try to maximize my utility and make decisions on what to buy. That's a simple example.
Wonderful, wonderfully explained. So I think that $5 is like a constraint.
Yes. So that's the budget constraint we have. Like that, we might have several constraints. So I might say I cannot buy more than two candies for my daughters. That's another constraint which I add.
Sure.
Or not more than one Coke bottle for my husband. So another constraint I add. So you have a solution space restricted by these constraints. It could be budget or any other. And within that solution space, how do you optimize? How do you get the maximum objective? So in this case, my objective would be my satisfaction, right? So it's easier if you can have an objective function which is quantifiable,
Yeah.
right? So that's very important as well. In this example, it is a bit difficult, but then if you have a quantifiable objective function, you maximize something. Say, for example, in transport, you minimize the travel time in such a way that we still have we if you are doing a route, say for example, we are doing some delivery routes, right? I'm actually trying to minimize the total travel time and also trying to make sure that I'm visiting all the pickup and delivery points, and my truck starts from an origin and come back to the same place. So
Right.
I can simply explain it, I mean, define it like that. Yeah.
Very nice. When you started to say that, I started to think, what about all those objectives that are not so easily quantifiable?
That's one challenge always we face, you know.
So how do you now approach that? I mean, you have to quantify to employ mathematics to solve the problem for us. And I think that in itself is a good area for research.
Research, right? We do have a lot of researchers working on that. We call it as utility, right? Utility of the consumer is something which is not really quantifiable, right? So how do you quantify? So suppose we have different modes of transport travel from a place to another place. We have bus, we have cars, we have maybe another mode of transport. How people choose different transport mode, right? So it depends on their utility. And how do you quantify this? So I am not an expert in that area, but then I can say we do some choice modeling experiments to understand how people, we give them a scenario and observe how people actually choose a particular choice. And from that, we infer that non quantifiable values, which we call it as utility. So there are different methods where you can actually the things which you cannot quantify, do experiments. It could be a stated preference survey or any kind of experiments and infer that, the non quantifiable, say, for example, satisfaction of people into numbers.
This is right at the cusp of civil engineering, computer science, and I am now thinking even behavioral economics. And so there's human behavior that is that you're trying to essentially quantify at the end of the day, right? Let's go back to your humanitarian engineering idea and apply some of these thoughts there. Now, in the humanitarian engineering, let's take, you mentioned about evacuation. You talked about, when you have an emergency, so like a wildfire, how do you now create the evacuation system?
Hmm.
Um, in all of these areas, is there a role for mathematical modeling a priori so we are ready when the situation occurs? Or how would you design an emergency evacuation?
So, what we do is there is pre-disaster and post-disaster, right? So, we do have pre-disaster management strategies when we observe the transport network and see how vulnerable the transport network is, right? So, it's one of the study that we do. We look at the transport network and see if what happens if this link in the transport network get affected. It could be a disruption. It could be a short-term disruption or a long-term disruption. How that impact the traffic movement within the network. So these kind of analysis which we do, and also we advise government on looking at the network, how resilient the network is. If there is an earthquake or if there is a wildfire in this particular area, how should we evacuate them? Which are the networks? Which paths they should be following? And which are more vulnerable links in the network. So if we find there is vulnerable links in the network, when I say vulnerable links in the network, if there is a disruption in that network, the entire flow get affected, right? We try to find alternate paths so that in case if you have any disruption in that link, still the evacuation will happen smoothly, right? So that's some pre study that we do. So we advise on investing budget, how much, which link to upgrade, or say that, if there is a disruption, when people try to evacuate from one point to another, these are the bottlenecks that you're going to face. So how can we deal with that? So we advise on these are the links which will get congested. Why don't we upgrade this link? Why don't we, if it is a 2-lane link, why don't we make it a 4-lane link, right? Or you would say that, okay, this link is going to get affected. Why don't we have an alternate path so that in case of an evacuation, this bottleneck would not impact the evacuation? So this is pre. And then during evacuation, it's just people behavior, right? They evacuate based on the advice from the governments, majority of them, and some of them just evacuate. And then post evacuation, you have the studies that I have done is mostly on disaster relief management. So I do a lot of research on how you can actually deliver emergency services, food, water to the disaster relief areas. So this kind of study we do.
So we
So everything has optimization as the foundation.
wonderful. And the third part, disaster relief delivery. Are you taking into account a disrupted transport network?
Yes.
So you have a model for what could be disrupted, and you're sort of trying to.
Yes, we do have simulation models, right? So we study, that's where now this digital twin, AI, and all are helping us, right? So we actually replicate the real network into non-real simulation models. And we study what if this link get if impacted, what is the impact, right? And then we come up with strategies,
Sure.
right? And coming to post-disaster relief network, we collect data, and based on the data information we know that this is how the network looks like, these are the disrupted links. Based on that information, we do the disaster relief operation. Yeah.
This is one of the easiest conversations for me to have. The idea of digital twin and AI, right? That you said, it just seamlessly leads us into that part. Help us understand, what is a digital twin?
Digital twin is actually you're replicating the transport network,
Okay.
right? So
Or tomorrow it could be any other system.
Yeah.
The general idea.
I'm just saying related to it's a replica of transport system, right? So today for the digital twin to work, we need enormous amount of data, right? That's we do have access to data. That's one advantage why we could use digital twin now, right? So we and in the digital twin, we can simulate anything. So in the network, what happens if there is a disruption in a train service, right? So say, for example, there is a major train line that takes people from the CBD to regional areas after work or you early morning to the work, right? So what happens if that train link gets impacted? What is the impact on the entire network? Because you might have to have as a replacement of train link, you need to have replacement bus, or you need to run more metro services. So all of these simulation scenarios you can do in your digital twin. So even before it happens in the network, we will have an understanding if such a thing happens, how does the network get impacted? So that's the benefit of digital twin. We used to do this before also. We do simulation studies. Now it's digital twin has made it a bit more easier.
Okay. And the role of AI.
Yes.
With all this data that is now coming available, what are some ideas that, where AI can come to help transportation or mobility engineering?
The decisions that we make, now we can do a lot of predictive decisions. So we do have AI which actually captures the pattern. We do have machine learning which actually captures the pattern from the data which we have, and it can actually predict what's going to happen next, right? If there is a scenario that if an incident happens or if a disruption happens, how it's going to impact, using the data, AI can predict. And again, imagine you might have more experience in it. In three decades back, how does the traffic signals work? We used to have very fixed.
Wait, what makes you believe I'll have experience from decades back?
Sorry. No, you are definitely more extreme. May. So, how does the traffic signal works? It used to be a fixed traffic signal, right? So we go there, we collect the data, we count how many number of vehicles are manually counting, right? Go there, stand there, manually count how many number of vehicles are moving. And based on the estimate on the number of vehicles moving, we say, okay, 20 seconds for this approach, 30 seconds for that approach, because we have more traffic
Correct.
in that.
I remember exactly what you're describing, because you are stuck there. Nobody's going the other way, and you're seeing the red light.
Yes. So that's exactly the problem which we had, right? Because it's a fixed traffic signal which we used to have.
Correct.
Then that evolved into a little bit more of an actuated traffic signal, right? Or an adaptive traffic signal, where we installed sensors. Sensors can be in terms of detectors on the road, or it can be a camera or any type of sense which actually sense the vehicle, right? And then we try to actually modify the green time, red time based on the number of vehicles. If there is no vehicle on an approach, there is no need of a green signal there, right? So this came into picture, right? So and again, that also it's impossible for us to make it completely dynamic, right? So what we will do is we take a day, and then we split the day into different plans. We might have an off peak plan, we have a peak plan, then we have an off peak plan, then we have a peak plan. Based on the data which we have, we actually fluctuate the green signal based on the traffic. Making it completely dynamic is still a challenging part, right? with the AI and with the digital twin, that became a little bit more easy, I would say. Now we have more of a dynamic traffic signal system in most of the places with the information in terms of that data coming in. It's possible.
And you could also synchronize signals.
Yes. So that actually helps us not just improving the a particular intersection. It actually helps improving a set of intersections, connected intersections, I would say. So if I reach an approach 1 and I'm heading to approach 2, I have green here, and I would prefer when I reach the intersection 2, I get green, right? And platoon of vehicles could pass through through the green light, right? So that is more possible now because of the information that we have, the more and more data that we have. That requires a lot of data, right? Yes. That's possible. So that's one example I can say.
Wonderful. So I think when I step back and look at everything we've talked about, right, between traditional civil engineering transportation to using actuation, borrow your word here, to now the world of AI, this discipline has evolved almost completely unrecognizably, hasn't it? And blurred the boundaries between civil engineering and computer science in some way. Um, so tell us about where this is headed. What can we expect 2, 3 years from now?
We call it as disruptive technology. The advancement in technology is the reason why it is evolving, right? So previously we used to have fuel based vehicle. Now we have electric vehicles. We have autonomous vehicle, right? So and as the technology improvises, the system also keep improving. And what I see is as the technology improving, how the performance of the system also improving. Now, where we are heading to is now we know that we are looking at electric vehicles. So one example I would say, when electric vehicles comes into picture, how the network should change, whether the current transport infrastructure is it enough to cater for the electric vehicles, right? So these are the questions that we ask. So and autonomous vehicles. So if we introduce autonomous vehicles into the transport network, is the current infrastructure enough to cater for the autonomous vehicle? So based on that, our current transport systems, how we approach transport system also changes. So it will keep changing. In the next 10 years, what we are going to see is flying cars. That's something which I do research also. I do have a group of students it's an interdisciplinary as well. Students come from different field, electrical, computer science, mechatronics, mechanical, civil, comes together and work on it. Um, on how a flying car network will look like, and what are the behavioral studies that we do to analyze the behavior of people towards flying cars. So what I'm trying to say is, as the technology evolves, transport system evolves.
Wonderful. You've done a good job of batting for transportation. Flying cars, I can imagine why a young student should be really excited. So tell us more reasons why a good young graduate out there should say, I'm excited about transportation engineering, like you were some years ago at NIT Calicut.
For students, I would say pay attention to the everyday mobility.
Okay.
And if you are asking a question why there is a traffic jam, what can we do to improve the traffic jam, or why the buses are crowded, or why I don't have accessibility to bus? If you are asking such questions, then you are at the right place.
And increasingly, we used to think air and water are like requirements for life, right? But today, mobility
Yes.
is almost a requirement for livelihood,
Yes.
right? So this is like you're serving a fundamental need of society by coming into and becoming a transportation engineer. Now, in a typical civil engineering curriculum, you may have one course in transportation engineering. If I want to specialize, what are some options? Are there master's programs, or how do I get myself ready for the kinds of things you were describing?
That's a very good question. So I believe the curriculum is evolving, and we do have much more opportunities for learning transport within the undergrad program as well. Where I teach, actually, we do have various electives that you can take in transport. Um, So if I remember the question correctly, what students can do extra then, right? So generally we will have maybe a core course in transport, and probably they will learn pavement engineering in that, or transport plan, traffic engineering in that. I would recommend them to actually look for some short courses in
Okay.
transport if they are really interested in transport. They
These are for undergraduate students that you're advising.
there are several short courses that they can learn, and if not within transport also, if within other courses, if they learn fundamentals of graph theory, fundamentals of optimization, that can be applied in transport as well. Go look for short courses that excites you, and if you can learn some simulation softwares which can be applicable in transport. So we make sure that every transport and every undergrad students that graduates will have some exposure to some of the transportation simulation softwares which is used in industry and government, and some additional flavor to transport in terms of short courses.
Okay. What about master's programs? Can somebody do a master's in transportation engineering?
Yes, there is. I think almost all the universities which has higher degree research or postgraduate program has a transport as a discipline itself. Within transport itself, you have various verticals. You have travel demand management, traffic management, optimization, which sits under OR, and then you have behavioral studies. So there are several other aspects within transport as well. That's one of the major PG program that sits under civil.
So clearly, in the last 25, 30 years, civil engineering, which was looked at as buildings and structural engineering, has undergone a complete transformation, and transportation engineering is probably largely responsible
Yes.
for that change of the image of civil engineering in some way. Now, let's come back to humanitarian engineering and human mobility. If I am excited about that space, how do I enable humanitarian um, mobility or humanitarian disaster relief? Uh, where, as a student, can I go to learn about these things? Are there resources? Is this a very nascent discipline? What can I do?
There are plenty. So one thing which I forgot to add to the undergrad students is do internships. So when you are, I'm sure internship is one of the core part of your undergrad program, because not just the theory that you learn in the program, try to apply that in practice. That's the best way to go for is try to identify places where you can do internship. So if there are plenty of transport organizations, industry where you could try and get an opportunity to do internship, that would be a way to actually get more exposure to transport engineering.
So when you say there are plenty of organizations, these are like railways or like airlines, or what sort of companies?
There are plenty of industry that you do transport engineering as well.
Okay.
I'm not across what is available in India. We do have many consultancies in Australia that do transportation. So, what we say is students who do postgraduate in transport engineering, if they are really keen on doing deep research, I would encourage them to do a higher degree research in PhD and go into academia. But if you're interested in actually uh, applying what they learn, I would recommend them to go to the government, right? Because they work closely with the community and they can apply the ideas or the problems that they work on into the, closely with the community. Or if you want to have diverse experience, I would say work with consultancies that deals with transport problems, who advises on government or who does transport related solves transport related problems.
So your closing thoughts for our young students out there listening, saying, I'm confused in various disciplines of engineering broadly and then within civil engineering.
I would say stay curious. You have to be absolutely curious about, and what makes you curious, pursue that, right? Keep up to date about the technologies that we have. strengthen your foundational skills, keep improving your skills. There are lifelong learning opportunities, there are internship opportunities, anything and everything that you grab, go for it and stay curious.
Wonderful. On that note, this has been a fascinating conversation. I learned several new things about a new dimension to transportation engineering. Thank you very much, Divya, for stopping by and for helping us, understand this very complex space.
Thank you so much, Professor, for having me here. I know it was on a short notice, but thank you so much.
No, it's the delight was all mine.
Thank you.
Thank you. This has been another episode of the Professor Mahesh podcast. Until we meet again, be well, do good, and keep in touch. Goodbye.